We're about done with Unit 2. Let's look. Just practice quiz together. I appreciate that. I always feel so awkward yelling across the room.
Might as well sit right up on him.
Right. I appreciate you, girl. I'm gonna write answer key on here. And then talk about this first page here. So questions 1 through 4 are the exact same type of question. We're looking at 3 angles, and we want to know if those 3 angles could form a triangle. So how would we know if they form a triangle or not? What do you need to do?
I think you have to add them.
Yeah, you're going to add them together. Okay, so what number is it that you're looking for when you add them together?
The 2 smallest sides.
Yeah. Oh, okay, so that is with sides. This time we're looking at angles. So whenever we're checking if 3 angles make a triangle is made up of 180 degrees. So if they do add up to 180, then it is a triangle. If they don't, it's not a triangle. So let's check that. So what's 23 plus 5 plus 151?
We're in the same day.
Ooh, it's pretty close. 179 degrees. So is that a triangle? No. So for these, you're going to circle yes or no. And then the second part asks, if it's a triangle, state which type of triangle. So you guys remember what the 3 different types are that I put up here, what those mean?
Acute means less than 90 degrees.
So with an acute triangle, here, we'll take some little notes, make sure that we have it for day of. All 3 angles have to be less than 90 degrees. All 3. And then for a right triangle, I only need one angle that's right here. So we need one angle exactly 90. And obtuse, that's where we'll have one angle more than 90. So with the right and the obtuse, we're just looking for one angle measure that's 90 or more. With acute, all 3 of them have to be less than 90. So this is not a triangle. So technically, you could just put, I always put NA for no answer or not available, no answer. Or if you were just feeling like an overachiever, we could identify if it was a triangle, what kind would it be?
That was
Obtuse. We have an angle that is bigger than 90, 151. So I'm not going to count you wrong if you don't label it as obtuse, but there's an obtuse angle in there. All right. Number 2. We're going to add these together. Let's see what they do. What do they add up to?
180.
180. So is it a triangle?
Yes.
Yes. What kind of triangle?
that's right.
Right.
Right. Good. Got a 90-degree angle. So that is a right triangle. Okay. Number 3. Add these together, see what we get. Definitely added them.
180.
Perfect. 180. So is it a triangle?
Yes, and I think it's an obtuse.
Yes, it is an obtuse. Perfect. That 127 degrees tells us that. Yeah. Okay. And number 4, you guys tell me if that's a triangle. No, it's not.
Oh, yeah.
What's it add to?
Yeah, it's up to 179. That's what.
Ah, 179. So it's really close, but not quite. So, is it a triangle? No. And for your type, we could either say NA for no answer, or if you just felt like being fancy and telling me what it could be,
Cute.
acute. Yeah. All these angles are smaller than 90. So we could say acute. Okay. Any questions about checking if 3 angles make a triangle, or you guys feel good about that? Let's look at number 5. We are solving for all missing angles below. I decided instead of giving you a bunch of problems, I'm just going to put them all in one, like this. So I think the first thing we should do is think about what angles are we even able to find. We're probably not going to be able to do them in order, A, B, C, D, E.
You could probably find those. You can probably find C.
Yes, we can find C. How are you going to find C?
And 48 and 31,
Mm-hmm.
and then subtract that from 180.
Okay, let's see. 48 plus 31. What's that equal?
I know what.
4, 5, 6, 7. I'm getting 79. Oh, are you telling me the measure of C?
I'm thinking of the other one.
You're right. You're 100% right, Ritson. So 79 here, and then we just did 100 minus, or 180 minus 79, and that gives us the 101 you're talking about. Okay, so angle C is 101 degrees. Perfect. What else could we figure out? B? What's B gonna be?
101.
101 also. How'd you know that?
Congruent.
Yeah, they're congruent. Those are vertical angles, so they're gonna have the same measure. So 101. Beautiful. What else could we find?
D and E are congruent too.
They are congruent, so we could go ahead and mark those. We know they're the same.
I think for the other triangle, you have to do 100.
Now we can find A.
Go ahead, Ritson. What
You have to do 101 plus 44.
Yes, we do. And that's going to do exactly what both of you just said. That's going to help us find A. So 101 plus 44 is 155. Am I right there?
Hi.
Yes. Hello.
Sorry.
No, you're okay. Let me
I
pause
need
it.
to borrow something. Do you
Okay. So we got, am I correct there? 155 degrees?
Yes.
Subtract that from 180.
Perfect. 180 minus 155 is 25. Sounds good to me. Right? I'll check. I don't know why that doesn't sound right, but I'm sure it is. Yep, 25. Sure enough. Okay, so which angle was 25 degrees?
A.
A. Here, 25 degrees. Okay. So we still need D and E. What are we going to do to find those?
Wait,
Yeah.
how do you get 155 from doing 101 plus 44?
Oh, I'm wrong. It's 145. Wow. Good catch, Ritson. What would I do without you? We're going to fix that. Thank you. I don't know why I was thinking 155. Can't rely on mental math sometimes. Tell you
And
what.
it's actually 146.
Yeah, Or 146?
No. Now I'm confused all the
I
way.
know, I'm messing everybody up. I was gonna say, I thought I drew this pretty accurately, and that does not look like a 25-degree angle to me. 35 feels a little more like it. So, I gotta let that dry now. Here, I'm gonna pause it while it dries. Sit and watch my whiteout dry. Okay, so we got 35 instead. Okay, perfect. How are we gonna find D and E?
Yes, okay, I think you have to do 180 minus 145.
Minus 145?
I meant 101.
Minus 101.
Yeah, I was looking at the one.
Okay, so why are you doing 180 minus 101? You're correct, by the way.
Yeah, so like, because I think they're like supplementary components.
Yes. Oh my gosh, you're making my day. So if we're looking at D or E, we know that these two angles together, B and D, they make 180 degrees. They're a straight line, they're supplementary. So D plus 101 is 180. So we could just do 180 minus 101. That's perfect. I'm going to use my calculator. Figure that out.
79.
Beautiful. That's what I got too. That way you got, Ridson? Got 79 degrees for D. And how about E?
Same thing.
Same thing. Those are congruent. Awesome. Good. Okay. You guys have any questions about the first page?
Is it always like, is there always like D, B, and like that? It's always gonna be that number minus 180?
Yes. If they are on a straight line together like this, they're always going to add up to 180 degrees.
Okay.
Perfect. All right. Let's go. Now we're looking at side lengths. So for number 6, 7, 8, and 9, we are given sets of side lengths, 3 side lengths, and we have to figure out if they could form a triangle or not. How do we figure that out?
If the two sides are greater than the biggest number.
Yes. So we want to add together the 2 smaller sides. So I'm going to make a note of that on my quiz. 2 smaller sides together. Bigger. Side. What if they're equal to the largest side?
Well,
Then it's not
Yeah.
greater.
That's right. You won't be trying. So let's look at number 6. Which 2 sides should I add together?
12 and 24.
12 and
Good.
24.
So 12 and 24 need to be bigger than 31. See what that gives us. What's 12 plus 24?
35.
36.
Oh, 36. Yes. Goes off by 1. That's okay. 36. Is that bigger than 31?
Yes.
Yes. Perfect. So we circle yes. Okay. You want to try the other 3 on your own, and you guys can look up here and check your answers. I feel like y'all know it, so I'm going to just start solving them on my own. You guys check with mine. We are just rock stars. Let's go ahead. 10 and 11. Man, y'all, we're already almost done. That's crazy. Okay. I swear, I thought whenever I was making this last night, I thought it was going to take so long, but you didn't. Y'all are just really smart. So now we need to solve for the missing side length of each right triangle. Do you guys remember what we used to solve for missing side lengths? Only 4 right triangles.
I think it's like 30, 36. Hold on.
Those are special right triangles. So those you're going to see on the next page where I have the angles given to you.
Okay.
But on this page, we don't know what any of the angles are. We just know the 90. There was something fancy that we did. Starts with a P, and it involves 3 letters. And
No. I wasn't here a lot, but
you might have missed. I bet you know it though. Don't want me to just tell you.
Yeah.
You remember the Pythagorean theorem?
Yes.
A squared plus
B squared equals C squared.
Yes. Okay, perfect. So on your practice quiz, let's make a note of that so we don't forget it. All right. I'm gonna put it down here. A squared plus B squared plus
Equals.
goodness. Paper's gonna be so thick with whiteout. C squared. There we go. Now, which side always has to be C?
Say,
Yes, that the slanty one, the hypotenuse. So the one that's right across from the 90-degree angle, that has to be C. So 27 is C for this question. Okay. And the other sides, it doesn't matter which one you put as A or B. But I'm going to label them. I'm going to look at number 10. I'm going to call 12 my A. Call 11 my B. C, I don't know. So how should we set up this equation?
You would do A squared, so you would do 12 squared. And that is 144.
Perfect, 140.
And then you would do B squared,
Mm-hmm.
which 11 to the second power would be 144. Wait, 120.
Oh, 121. Super close. Let's see.
One. So C would be 265.
Okay, so we've got 265 is C squared, but we need to find C. You remember how we get rid of a squared C?
the root.
The square root.
Divided.
Yes. So whenever we have the square number here, we've got C squared. The opposite of squaring a number is doing the square root, just like this. So we're actually going to find the square root of both sides here. So that's square root.
5.09.
Let's see. Type it in. Second square root 265.
Okay, I did.
Or did you type something in differently?
I did 26.
Oh, well, that'll give you a different answer for sure. I bet you'll get the same thing.
Yeah.
Perfect. So that square root gets rid of the squared symbol, and now we have C by itself equals, and we're going to do 2 decimal places. 16.2, would it be 7 or 8?
8.
8. We're going to round up here. Perfect. So C equals 16.28. That's our answer for 10. You guys want to try 11 on your own, or do you want to do it together?
Sure. But I can do those.
Okay, I'll work it out up here, and we'll see if you guys get the same thing that I do.
We don't come on home.
So far. Tell me if you get the same thing. Get the same thing?
Yes.
Sweet.
Oh, I didn't use a calculator.
Oh, you're okay. No biggie. You just tell me what you get whenever you get it. So I'll explain that again here because I wasn't recording. But our A has to be one of the side lengths here that makes up the 90-degree angle. And B is the other side length that makes up the 90-degree angle. And C is always the hypotenuse. Always the side that's right across from the 90-degree angle. So that'll make our equation look a little bit different. Once you get that rearranged, tell me what you end up with. You got it?
Yeah.
Perfect. All right. Last page here. So here's the special right triangles. Have you start by labeling the
I remembered it.
lengths. You did?
Yep.
Okay, tell me my 45, 45, 90, what are my lengths gonna be?
So from A to B, that's going to be X right equal to. And then B and C are X.
S.
And then A to C is X.
Amazing. Beautiful. Okay, how about 13?
Um,
60, 90.
The hypotenuse is 2x.
Yeah. Okay,
And then F to E is x.
perfect.
And then from D to F is radical, well, x radical 3.
Yes. That's crazy you remembered that. That's awesome. Pretty good. All right, so we've got all of these labeled. So with 12 and 13 both, I have given you one side for each triangle. So I get number 12. I gave you that AB is 45.
So would you take 45 divided by the square root?
Yes, you would. So how do you know to do that?
Because that's the opposite of square root, is dividing.
Yes. So it's not the opposite of squared. We're doing the opposite of multiplication because we're really saying x times radical 2. So we're dividing by radical 2, but you're 100% correct either way. So we could set up the equation. I always like to say what my values here are equal to as well. So I know AB is 45, that's given, but I also know AB equals x times radical 2. So now I have a whole equation set up that I could solve. And then I know BC and AC, or BC and CA, are both x. So whenever I solve for x, I've got my other sides.
So you would take 45 divided by radical 2.
Yes. What you get?
X equals 31.82.
Yes, 31.82. Beautiful. So now we have BC and CA. They're the same. Beautiful. All right. Y'all both get that?
Yep.
Good. Okay, you want to try 13 on your own?
Can we go with it together?
Yeah, absolutely. Let's do it. So let's start by setting all of these values equal to the given special lengths with the x's and the radicals. So DE, what's that length? What do we know?
2x.
Yeah, 2x. EF, what's that one?
X.
X. And FD, what's that?
68 equals x radical 3.
Yes, x times radical 3. So what do we need to solve for first?
FD.
For FD. So we already have FD.
You can do it.
We already have FD. We've been given that it's 68. We are using FD to solve for something.
X.
Yes, we're solving for x. So what are you going to do to solve for x?
Divide it.
Divided by radical 3.
Perfect. You're just going to divide by radical 3. And it's going to tell you what your x value is.
X equals 22.66.
I got something a little
I got
different.
48.
So I typed 68 divided by
Hold on.
radical 3.
I forgot to do the radical part.
Oh, well, that'll do. Did you get this number, Ritson? Perfect.
And as I said, you know,
Oh, you didn't? What did you get?
I did radical 2 instead.
Oh, okay. I got ya. Yeah, these are super easy to make those little mistakes on. Gotta be so careful.
Now I got that number.
Good. So x equals 39.
2.26.
Yes, 0.26. Perfect. So how can we use the value we found for x to find the other angle, or not angles, the other side lengths?
We know E and F is already 39.26.
Yeah, so let's go ahead and do that. 39.26, because we know it's x. Circle. And how would we find the last side?
So you would pick 2x equals 39.26, and then you would divide it.
So we already know what x is. We don't need to solve for x. Yeah.
You just put it in parentheses.
Yes, we're just gonna plug x into 2x. So you're just multiplying it by 2. So really, it's 39.26 times 2. I just replaced x with that.
Do you get 78.52?
Let me see. 78.52. Yep, that's what I got. Perfect. Answers for DE and EF. Beautiful. So you guys got all those?
Yes.
Okay. Do y'all have any questions about these types of problems? These are definitely the trickiest of what we've done, but I feel like y'all got it. Just don't get more confident with it. Okay.
So,
That's it, other than our bonus question. So this is optional, but it will give you bonus points if you answer it correctly. So let's talk about this. This is about what we introduced last class. We talked about triangles that are congruent. So first of all, what does that mean for two triangles to be congruent?
they're the same.
They're the same. So for two triangles to be congruent, they need to have all three angles the same, all three sides the same. So, I'm going to print this up here. Same. Just in case we forget. So the next part of this bonus says, if so, what type of congruence do they have? So we talked really briefly about different types of congruence. And I'm going to give you a few to choose from here. We have SAS, that's side angle side. And that's where you have an angle in between two sides, and those are congruent. Then there was SSS, side, 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 meaning we have three congruent sides. I believe we also talked about ASA, angle, side angle. So I'll walk you guys through this one since this is much newer. So all we're really doing in this problem here is we're labeling all the things that we know about these two triangles. So they have given this to us. We know that AC is congruent to DC. So let's find AC. And I see it right here from A to C. And I know it's congruent to DC. So how could I mark that those two sides are the same? Yeah, with one little tick mark on both of them. That shows that they are congruent. And now I know BC is congruent to EC. So those are just down here on the bottom side. How could I mark that these two are congruent to each other?
2 lines.
2 lines, good, 2 tick marks. Okay, so I have 2 sides that are congruent to each other. Can I say that anything else is congruent?
A and B and D and E.
A, B, and then D, E.
Yeah.
So we don't know for sure that they're congruent. We don't know for sure because even though these are the same length, what if they're opened at different angles? There is one thing that we can for sure say is congruent. I'll give you a hint, it won't be a side.
C is congruent to C.
Yeah, the angle C here. We've got these are vertical angles, right? Just like on the first problem, we knew B and C were congruent to each other because they're vertical angles. We can do the same thing here. So we're going to mark these as congruent with the little arc. Now, whenever we have angles of a triangle, we actually label them a little bit differently. Instead of just writing angle C is congruent to angle C, that could mean this angle, that could mean this angle, that could mean this, that could mean this. We want to actually use 3 points to label. So we're going to call it angle DCE, where your middle letter is the vertex of the angle, and the outside letters are those rays pointing out, or in this case, sides. So we're saying that that one is congruent to angle what? How would we name the other angle in the same way?
ACB.
ACB. Okay. So you'll earn bonus points for recognizing that those angles are congruent in between each other. There might also be given 2 sides up against each other that could be congruent. So let me show you this. If I had a triangle like this, where I had A, B, C, D, and I knew that this was congruent, but I know nothing about angles, I know that these sides, BD and BD, are also congruent because they're up against each other like that. So in that case, we'd say BD congruent to BD. So sides we only have to label with 2 letters, angles we label with 3. So, are these congruent?
Yeah.
Are congruent. Which one of these, SAS, SSS, or ASA, which one would these triangles fall into? How do we figure that out?
SAS.
Side.
Ooh, okay, so let's look. Side, then there's a side, then there's an angle. Which one is in the middle? The angle's in the middle. So we want to write that angle in the middle there like that. We have a side, then an angle in the middle, then side. So this would be called SAS congruence. Since we have a side, I'm going to actually do it sideways. Side, angle, side. We can kind of read it just how we see it.
Do we have to write yes too?
I'm going to tell you right now, the triangles I give you will be congruent. So I'm not going to not give you points if you don't say yes. I'm not sure why I even wrote, are they congruent? Whenever I give you the quiz, I'll probably mark this off and just ask, what kind of congruence are these, or do these triangles have? And then I'll have you label how you know they're congruent. All right. Okay. Any questions about that. Y'all feel okay about it?
Yeah.
Okay. So it is 2:58, meaning there are still 30 minutes left in this class. However, that is the practice quiz. If you feel good and you're ready to take a break, you're welcome to go. You're free to leave. However, if there's anything that you would like more practice on, or if you have other questions about any of this, I'm happy to stay and help. So if y'all feel good though, I'm not offended if you go.
That feels pretty good.
Okay, well, good deal. And that recording then put this up for everybody. Oh.